We're at the stage now where we're going to be going into more applications of differential calculus. So, I remind you the derivative represents the gradient of a graph of a function. It's really the rate of change of a function, but the graph is rate of change in y with respect to x. In other words, change in y over change in x. So there we are. The gradient of a curve is determined by the gradient of the tangent to the curve at that particular point. So straight lines are easy. It has a constant gradient. But when we get to curves, it depends where you are on the curve, and you draw tangent to that curve, and that is the rate of change of that function at that stage. So let's have a look at these ones. Find the gradient of the tangent to the curve at the given x value, y equals x squared at x equals 5. So there's y equals x squared. There's x equals 5. So we're finding the equation of that red line. We're finding the equation of that tangent. Now, to find the equation of a line, we need to know the gradient, and we need to know one point through which it passes. Well, the gradient we're going to get using differentiation, and the point can only be that point of contact where this line meets the parabola, and we know the x value is 5, so we need to substitute the 5 into the original. But at this stage, we're only finding the gradient of the tangent, but after that, we're going to be finding the equations. So we differentiate y equals x squared and simply substitute in x equals 5, and there's our gradient 10. If we look at the next one, y equals 4 over x at x equals minus 2. Well, there's the graph. It's a hyperbola of y equals 4 over x. And there is the tangent at x equals minus 2. We can pretty much see that it's got to be y equals negative x. Negative 1, in other words, because it's going through the x-intercept of negative 4 and the y-intercept of negative 4. But we must go through the procedure. So first thing we have to do with y equals 4 over x is we have to write it in the form which we can differentiate, 4x to the minus 1. Now we go into the differentiation. Multiply down, subtract 1. So minus 4x to the minus 2, which is minus the negative of 4 over x squared. To find the gradient of the tangent at x equals minus 2, we're going to substitute minus 2 in for x. And we get minus 4 over minus x squared, which is minus 2 all squared. And it gives us minus 1. So there's the gradient. Now we're going to find the equation of a tangent to the curve. That's what I was talking about. We need to know the gradient, and we need to know the point through which it passes. So let's determine the gradient first. The gradient comes from the derivative. So we differentiate. We're going to substitute 1 for x, and there is the gradient of this tangent, m equals 5. Now we need to find a point on the line x1, y1. So point x1, y1. Now that point can only come from where we know x is equal to 1. So we now substitute 1 into the original equation. So it was 1 into the derivative to give the gradient, 1 into the original equation to give a point. And there we are. So therefore we have 1, 4 is x1, y1. Now we can go in and find the equation. I remind you that's the easiest way to find the equation of a straight line. Y minus y1 equals m into x minus x1. So y minus y1 equals m into x minus x1. We're going to substitute 1 for m, and we're going to substitute 4 for y and 1 for x. And that simplifies to y equals 5x minus 1. So there's our equation of the tangent to y equals x squared plus 3x at x equals 1. And having a look, it looks about right. It's got a pretty steep gradient, 5. It has a y-intercept of -1. Well, there we are. So Autograph got it right because Autograph drew both these graphs. Now, exercise 1, find the equation of tangents. The equation of tangents. The second one, what is the value of a if the gradient of the tangent to the curve y equals ax cubed is 4 at x equals 1? Well, that tells us that the derivative is 4 at x equals 1, so we differentiate, substitute 1, and equate to 4. Find the points at which the gradient of the tangent to that curve is 1. Well, the gradient of the tangent is the derivative. So what it actually said is find the points at which the derivative of the graph is 1. So we're going to differentiate that and put it equal to 1 to solve. Pause and try it yourself first before we go through these. So let's continue. So we're going to find the equation of the tangent of the curve. So we need the gradient from the derivative, and we need a point from substituting the x value into the original. So there we are. We found the point. I've substituted we substituted 1 into there. I've substituted -1 into there, and I've substituted a half into there. So there are our 3 y values. There's the derivative. Y equals dy by dx is 4x minus 3. Now we're going to substitute each of these x values into the derivative. And now we have the gradients. So now y minus y1 equals m into x minus x1. For the first one, m is 1, x is 1, and y is -1. And so we go substituting the appropriate values into this equation for each of the other two. Let's have a look at 2. Part 1. The gradient of the tangent of the curve ax cubed is 4 at x equals 1. Well, we're going to find the derivative first because we're talking about the gradient of the tangent of a curve. And what this says is the derivative is 4 at x equals 1. So we're going to substitute 1 in and equate it to 4. And we get a equal to 3. Substitute -2. Substitute 2, x equals 2, and equate it to -2. There's my answer. This one, substitute a into the equation, substitute a into the derivative, because a is the x value, and equate it to a squared because that's the gradient. So that's the value of the derivative at x equals a. So there we are, 3a times a squared, and we have a factorization. Now this a equals 0 is really trivial because if you think about it, that's no longer really the graph y equals ax cubed because it's y equals 0. So we'll call it trivial. That's what we do in maths when it gives an answer which has no value. Doesn't mean it's undefined or anything. Here's the third part of exercise 1. Find the points at which the gradient of the tangent of the curve that is 1. So in other words, the derivative of this must be equal to 1. So we're going to differentiate first. Oh, well, I've just said what dy by dx equals 1. So that means 3x squared minus 11 equals 1. And we're going to solve for x. Now, don't forget, if you have x squared equals 4, then don't forget the plus or minus. Square root of 4. Substitute in to give you y values, because this says find the point. And we have two y values, so we now have our points. Positive 2 goes with the negative 7, which was obtained by substituting positive 2, and negative 2 goes with 21, obtained by substituting negative 2 into the original. We're going to go on to exercise 2 now. Same sort of thing, but slightly more stretching exercises. Pause and try it yourself first before we go through it. Right, these here are really more exam type questions. So it takes you through it. So the function is defined by f of x equals x squared minus x minus 6. Determine f of 1. So it's taking you through the different steps. So f of 1 we just substitute into the original. F prime of x we differentiate. The equation of the tangent, well, there's the derivative. So that's the gradient. So we're going to substitute 1 into the gradient, 1 into the derivative, and we get 1 for m. And we've already found negative 6, so we know 1 negative 6 is our x1, y1. There we have y equals x minus 7. Number 2, see as a point on the curve of f given by that quadratic equation. The gradient of the tangent to f at c is 7. Right, first find f prime of x, so we get to differentiate. 4x plus 3. Determine the coordinates of c, so the gradient of the tangent is 7, so it means the derivative equals 7. So we're going to take 4x plus 3 and put it equal to 7. And we get x equals 1. Now don't forget we need to go on and find the y value, so we substitute that back into the original, and we get 3, so that gives us the point 1, 3. The function defined by g of x equals x squared minus 8x plus 20 is given. Determine the point on the curve where the gradient of the curve equals, that should say gradient of the tangent, I think, equals 4. Well, gradient equals 4. We can say gradient to the curve though. Gradient equals 4 means derivative equals 4. So there we are. So we're going to put 2x minus 8, which derivative equals 4, and we get x equal to 6. Now we need to find the point, and to find the point we need the y value, and to get the y value we have to substitute back into the original. There we are. So we now substitute 6 back to the original. So now we have our x1, y1, and we have our m being 4. Y equals 4x minus 16. Next, the functions g and f defined by g of x equals and f of x equals are given. Determine the gradient of the tangent to the curve of f at 1, 4. So we only asked for the gradient, so we've been asked for the derivative when x is 1. Oh, it's this one, sorry. I was looking at the wrong one. That's g of x. Let's start again. We've been asked for the value of the derivative of f when x is 1. I was puzzled and looking for a short while because when you put 1 into there, you don't get 4 for y. But of course, I was looking at the wrong function. 1, 4. Just age. Gradient to the tangent. So we want the derivative. So there we are. I've differentiated f. Now I'm going to substitute 1 in, and we get 5. So that answers A. The gradient of the tangent to the curve of f at 1, 4 is 5. 1 point on the curve of f where the tangent to the curve of f will be parallel to the line G. Well, for them to be parallel, their gradients must be equal. That being a straight line graph, that's pretty easy. The gradient has to be minus 4. So therefore, the gradient, and there's the gradient, derivative, must be equal to minus 4. So there we are. The gradient of f equals the gradient of g. So we've equated. Solving for x, we get x equal to 2 or 4. We substitute 2 into the original, and we get the y value 4, because remember, we're finding the point. Now, it's just 1 point, so there it is there. But you can find the other point, 4, 8, if you prefer. It's just great because we're only told to find 1 point.